Hello dear students, in this subject hydraulic engineering, today we'll start a new chapter, that is dimensional analysis. Okay, we know that we knew that dimension means mass. For mass it is m, the basic dimensions. Okay, you can express every variable with a dimension form, that is m, l, t, or temperature. For temperature is theta. Okay, so this, what is this dimensional analysis? So it is a method. It uses dimensions, okay, for solving any engineering problems. It helps in determining a systematic arrangement of variables in a physical relationship, combining dimensional variables to form non-dimensional parameters. Okay, the relationship, the physical relationship can be developed using this dimensional analysis. How it is developed? By combining the dimensional variables to form a non-dimensional parameters. You have to form a non-dimensional parameters, then you can develop the relationship. For an example, let Reynolds number. Reynolds number is rho Vd by mu. Okay, that let rho Vd by that rho Vd by mu, and basically this dimensional analysis is used for research purpose and for if you are doing any experiment. Basically, if you are doing any experiment, and let you are going to determine the physical relationship between these variables. Okay, for an example, let you are going to determine the R, expression for R, Reynolds number. We knew that R depends upon the density, velocity, density, dynamic viscosity. That we must know before doing this analysis. The variables on which this R depends, that we should know. So then we can, using these variables, we can form a non-dimensional parameters. Okay, then we can develop a relationship. So this dimensional analysis basically is used to test the dimensional homogeneity. Okay, let dimensional homogeneity of this R and these variables, that we can do. Let for a discharge is equal to velocity into area. We can develop relationship between this discharge, velocity and area using this dimensional analysis. So to test dimensional homogeneity on any equation of fluid motion, this is a dimensional homogeneity, discharge and velocity area, that we can do. To derive the rational formula for a flow phenomena, derive the rational formula, that I told that a expression for this R or expression for this discharge. If we know the variables on which this discharge depends, we know that velocity and cross-sectional area. If we don't know the variables on which that depends, then we cannot do this dimensional analysis. Then we cannot express this relationship, we cannot develop. So first we should know the relations, the variables. Then we can develop the relationship. To plan model test and present experimental results. Any experimental results we can present in a systematical manner. Means by expressing in a form, in a relationship form, we can express. Thus making it possible to analyze complex fluid phenomena. Let we are going to study something. Okay, in an experiment, we don't know the formula. We don't know the relationship, but we do know the variables involved in that study. The all variables we can combine. We can combine them with a to form a non-dimensional parameters. Okay, then the relationship can be developed. We know the dimensions, fundamental dimensions, fundamental quantities: mass, length, time, temperature, that is m, l, t, theta. The quantities expressed in terms of fundamental quantities are called derived quantities or secondary quantities. Like velocity is length per unit time. Okay, means the velocity depends upon the fundamental quantities like length and the time. So this velocity is called secondary quantity or derived quantity. Okay, what is the dimensional homogeneity? It studies that every term in an equation, when reduced to fundamental dimensions, must contain identical powers of each dimension. Let for an example, velocity. Velocity, L t minus 1. It is length per unit time, length L and t minus 1. So LHS and RHS is matching. It means the dimensional homogeneous equations, only quantities having same dimensions can be added, subtracted or equated. Means we can subtract, we can add. Okay, These things we can do if that it is homogeneous equation. We cannot do subtract or addition of velocity with area. Now velocity with their acceleration. Velocity with velocity you can do because it is dimensional homogeneity. Area with area you can do because it is dimensional homogeneity. For an example, pressure. Pressure is W into H. W is unit of water. H is the depth of water. So pressure, if we write in dimensional form, it will be ml minus 1 T minus 2. Pressure is force per unit area. Force per unit area. A force, you know, mass into acceleration divided by area. And mass into acceleration is m L T minus 2 divided by area is L2. So this will be ml minus 1 T minus 2. WH unit of water, that is weight per volume. Weight is nothing but that same as force. So that is the mass ml T minus 2 divided by L cube. So it will be ml minus 2 T minus 2. So H is L, so if multiply it, you will get ml minus 1 T minus 2. So now the LHS and RHS are same. The dimension of both is same. So this is called, that means this is called dimensional homogeneity, and this equation P equal to WH obeys the dimensional homogeneity rule. Okay. What are the different methods of this analysis? There are different methods: Buckingham Pi method, Rayleigh's method, Bridgman's method, matrix tension method. But usually these two methods are used. Okay, this two method is widely used. Okay, so we'll study only about these two method: Buckingham Pi method and Rayleigh's method. What is this Buckingham Pi method? In this method, first we have to find the number of variables, which is called n. N is like relevant variables. M is independent dimensions like MLT. Okay, if it involves the temperature, then theta. So then it can be reduced to a relationship between n minus m non-dimensional parameters. Means we can develop a groups of non-dimensional parameters. Pi 1, pi 2, like this we can develop. How many dimensional parameters? N minus m numbers. If n total number of variables and there is independent dimensions are m, so n minus y m will be the non-dimensional groups that we can develop, and these non-dimensional groups are function of this a pi 1, pi 2, pi 3. Okay, the total all the numbers like total n minus m numbers are function 0. Means pi 1 is function of pi 2, pi 3, or pi 2 is function of pi 1, pi 3, or pi 3 is function of pi 1, pi 2. In this form we can write is function of this pi 2, pi 2. Okay. To construct these non-dimensional pi groups, how to construct these groups? We have to choose m dimensionally distinct scaling variables, or the scaling variables, or it is called repeating variables. We have to write in repeating variables. For each of the n minus 1 remaining variables, out of this 6, m will be repeating variables, and n minus 1 m remaining variables, okay, we have to write one by one in each variables. Total n minus 1 groups, so remaining variables is n minus 1 variables, so one by one we will write in each groups. Okay, like here pi is variable 1, first variable, then scale 1, scale 2, scale to the power b, scale to the power c, scale to the power a. So these a, b, c are powers of these, okay, these repeating variables which are constant, and that is calculated, okay, by considering pi as non-dimensional. Okay, so and these variables dimension we know, and the scale 1, scale 2, scale 3 dimension we know. So a, b, c we can calculate. The powers should be equal. Means it should obey the dimensional homogeneity. So a, b, c we can calculate. So how to choose the repeating variables? These m variables which are repeating variables, how to choose? Because out of m variables you have to choose as repeating variables. Okay, so repeating variables must have fluid properties, that is called mass properties or dynamic properties. It must have flow properties like kinematic properties, velocity or acceleration like this, and geometric properties like length, diameter, or depth or height. Okay, these properties it should be involved. Okay, so the m number of repeating variables must contain one fluid properties, at least one flow properties, at least one geometric properties. Okay, let's solve one example, then it can be clear. After an expression in a non-dimensional form for the pressure gradient in a horizontal pipe of circular cross section. So how this relates to the familiar expression for frictional head loss? So it is saying to develop an expression for the in non-dimensional form for the pressure gradient in a horizontal circular cross section. So first we have to see on which variables the pressure gradient depends. Okay, that must be given in the question. Okay, that must be given in the question. So this pressure gradient is found to be, it depends upon the density, velocity, diameter, roughness, thickness, that is Ks, roughness, thickness, mu is the coefficient dynamic viscosity. So the dp by dx depends upon rho, v, d, Ks, mu. So total number of variables are 1, 2, 3, 4, 5, 6. Okay, total 6 variables, including that pressure gradient, including the term or the variable which we are going to determine. So first we have to write the dimensions. dp by dx dimension, this is the pressure for unit length, that is ml2 ml minus 2 t minus 2 rho b d ks. Ks is thickness. Okay, it will be L. So mu tau equal to mu into du by dx du by dy, that we know. So mu will be this tau divided by du by dy. Tau is nothing but pressure unit. Pressure unit is ml minus 1 t minus 2 divided by this is L minus t. L t minus 1 divided by L. So it will be t. So it will be L minus 1 t minus 1. Okay. So in next step, you have to write the number of relevant variables. Total variable is 6. Number of independent variables or independent dimensions are here. Independent dimension is m, l, and t. M, L, T, total 3. Okay. So non-dimensional groups. How many non-dimensional groups you have to form? Total n minus 1, n minus m numbers. That is 6 minus 3. That is 3 numbers of groups we have to form. Pi 1, pi 2, pi 3. Pi 1, pi 2, pi 3. So choose m, which is 3 dimensional independent scaling variables. Means repeating variables that I told. The repeating variables should be 3 m number of repeating variables, and that repeating variables, the 3 number of repeating variables you have to choose for this problem, and that repeating variables must contain one geometric properties like d, diameter. Out of these 6 these 6 variables, density is mass, it is a dynamic properties, it contains mass, velocity, kinetic properties. So rho, one is b, and there is geometric properties, diameter d. So rho, b, d is repeating variables, that should be repeated in all groups. In pi 1 it must have dv rho and d to the power a, v to the power b, a rho to the power c. And non-repeating variables, the remaining variables n minus m, that remaining 3, that is dp by dx, ks, and mu. Okay, that will write one by one in each groups. So in pi 1 we'll take dp by dx, in pi 2 we'll take this ks, and pi 3 we'll write this mu. Okay, in pi 1 we'll write this dp by dx. So pi 1 we'll write in this form: dp by dx, d to the power a, v to the power b, rho to the power c. D, B, rho are repeating variables, means it should be repeated in every in each group, pi 1, pi 2, and pi 3, all 3 groups. and these are the non-repeating groups. Only will write in the pi 1, not pi 2, pi 3. In pi 2 will write another, that is ks, and pi 3 another, that is mu. Okay. So now we have to calculate the a value, b value, c value. So considering the dimension of both sides, it is a non-dimensional parameter. There is no dimension. So m to the 0, l 0, t 0. dp by dx will write in mlt dimensional form, d in dimensional form, v in dimensional form, rho in dimensional form. So if we write, then if we equate these powers, so it will be 0 is will be equal to 1 plus c, 0 will be equal to minus 2 plus a plus b minus 3c, minus 2b minus b minus 2 minus b, it will be 0. Okay. So if we this three equation we can get, and cba, that is three this is a 3 constant. We can calculate this c value, b value, and a value. Now we have to put this c value, a value, b value, and a value, and we can get pi 1. Pi 1 dx to d to b to the power minus 2 rho to the power minus 1. That we can write dp by dx divided by rho b square. Okay. So pi 1 is over. Now come to pi 2. Pi 2 will write a ks into this repeating variables, d to the power a, b to the power b, rho to the power c. We know ks is nothing but only l. So if you know the l and is a non-dimensional parameter, then obviously we can write this l by d. It is l by l means it will be ks by d. Ks by d. Ks is the length. So if we solve it, the velocity will write here lt minus 1. Rho is how much? Rho is to the power c. So if we solve this ABC value, we will get this a as minus 1. We will get a as minus 1, b as 0, and c as 0. So we will get ks by d. See here pi 3 mu into d to the power a, b to the power b, rho to the power c. So here mu dimension is, you can write d dimension, b dimension, rho dimension. So if you solve a, b, c value, we will get c minus 1, b minus 1, and a minus 1. So here, if you put this a, b, c value, we will get pi 3 is equal to mu by rho b d. Okay, and we know rho by mu by rho b d, that is also, we can say, the reciprocal of Reynolds number. Rho b d by mu is the Reynolds number. Now the pi 1 is, we can take this as pi 1 is function of pi 2, pi 3. Okay, we can take pi 2 is function of pi 1, pi 3, or pi 3 is function of pi 1, pi 3. That we can do. Okay, so let pi 1 is function of pi 2, pi 3, because we are going to express this dp by dx form. So pi 1, let us take pi 1 is function of pi 2, pi 3, because pi 1 contains dp by dx. So this dp by dx divided by rho b square will be function of this ks by d and mu by rho b d. So here there is a scope for rearrangement. We can rearrange, like here mu by rho is just a function of this, of 1 by rho. Okay, this only, I am saying this only, 1 by rho, this you can write. It is a function of 1 by rho, means it is function of Reynolds number, you can write. It is function of r. Okay, means that we are free to replace any of the pi's by power of that pi. We can replace, or by product with the other pi, provided we retain the same number of independent dimensionless groups. Same number of independent dimensionless groups we have written, and we can rearrange. Okay, little bit we can rearrange. In this case, we recognize that pi 3 is a reciprocal of Reynolds number. So it looks better to use pi 3 as pi 3 to the power minus 1. So it is Ra. So it is a function of 1 by Re, that we can also write function of R. Okay, that also we can be done. It's as per rule. But it's not essential to do. Okay, it is not essential, but it can be done. And the pressure gradient, that we can write rho g into hf by L. That we know this. Let this expression we know. Rho g by hf. Why we are writing this? Because in question it is saying to express this. Here in question it is saying how this relate to familiar expression of frictional head loss. Okay, that's why I am writing here rho g hf by L. Frictional head loss, it is saying. Otherwise, it is not necessary to write this formula. Okay. So directly we can express dp by dx is this. Okay. So if we write form of this dp by dx here, gh, this rho g hf by l, if we write here, and we will get this hf as l by d into b square by g into a function of ks by d re. This is actually 1 by re. That also we can write re. As per our convenience, we can rearrange a little bit. So since numerical factors can be observed into a non-specified function, this can easily be identified with the dashes by equation. Okay, numerical factors can be observed into non-specified function. Means this ks by d and Reynolds number. Okay, that we can take. This is a function of this Reynolds number and the ks by d. That we can take lambda l by b square by 2gt. Lambda is nothing but the function of this ks by d, that is Reynolds number, that we know. This is informal analysis Weisbach equation we have written. We can leave this expression in this way. Okay, I'm just simplifying it. Okay, to write like this, so that Weisbach equation we know fl b square by 2gt, and you know friction factor, and that friction factor depends upon what? The roughness, thickness, diameter, and it depends upon the Reynolds number. Okay, that's why the lambda is written. Okay, it's a constant friction coefficient or friction factor you can write. Okay, like this we can develop the relationship. Coming to the next example, the tip deflection. Okay, delta of a cantilever beam is function of tip load W, beam length L, second moment of area I, and Vx modulus E. Perform a dimensional analysis of this problem. So the variables we know that lambda, delta itself, one variable, delta W, L, I, E. These are the variables. Total 5 variables. Okay. That has to write the dimensions. We have to write dimensions. You have to see the total number of relevant variables is 5, and independent dimension is we can take M, L, we can take a T. Since here L we can take and mt you can combine, because here mt to their minus 2, here mt to their minus 2. So mt, since it involves same power, we can take as L1 and mt to the minus 2, 1 we can take. So combine these two, 1 we can take. So total independent dimension we can take m2. Okay, and number of non-dimensional groups will be n minus m, that is 3. Total groups will be 3. Repeating variables will be 2. Groups will be here. So choose M2 dimensionally independent scaling variables. That is the repeating variables. Let's content geometric properties L. Out of these 6 variables, L repeating variables, and we can take E. E contains mass and time both. That's why E will take another variables. So if you take, you can take individually M, L, T as 3 variables also you can take. If you take 3 separately, then weight also can be taken in that case. So here since I have taken M is equal to 2, because M and 2 to the power minus 2, M to the power minus 2 combine one independent dimension. That's why 2 I have taken, and repeating variables are L and E. Weight we cannot taken now, because yes, weight can be taken and E also can be taken, because E contains mass and time independent both. Okay, weight contains only mass, so actually this E contains mass and time independent both. So create the pi by non-dimensionalizing the remaining variables delta I, W. This will be pi 1 will be delta by L. Alpha from algebra not not written here. So pi 2 is I by L fourth, pi 2 will be W by EL square. So here the pi 1 will be, just I am writing here, pi 1 will be repeating variables. Repeating variables are L and E. So L to the power A, E to the power B. And one non-repeating variables, one non-repeating, let delta. Let first one you take delta. In pi 2, L to the power A, E to the power B, and non-repeating take I. Here I. And pi 3, total 3 groups, L to the power A, E to the power B, Here W is taken as non-repeating variables. Okay. And after writing the dimensions of L, E, okay, delta, we'll get A as -1, B as 0. So we'll get delta by L. Here A will be 1 and B will be, sorry, A will be -4, B will be 0. So here it will be I divided by L4. Here A will be -2 and B will be -1. So it will be W by E L square. Okay. So if we write the basic dimensions, okay, then we can solve this ABC. Then set out the non-dimensional relationship. Pi1 is function of pi2, pi3. Since we are going to determine this expression for this delta, so we can write like this: pi1 is function of pi2, pi3. So delta by L is function of L by 4 and L W by EL square. Okay, this in this form we can leave it. Up to this it is correct. So this is as far as dimensional analysis will get us. Little theory shows that as per theory we know that for small elastic deflections delta is 1 by 3 W L cube divided by L EI. Okay, this is as per usual equation. Okay, so this W by L will be 1 by 3 W by E square into I by L minus 1. Okay, so in this form you can write. Consider another example. Here, so that velocity through a circular orifice is given by square root of 2gh function of dyh and mu by rho bh. Here n is 6. Total variables is velocity 1, g is not taken, h is taken, d is taken, 1, 2, 3, 4, 5. Yes, g is also taken as variable. Velocity g, h, d, mu, rho. Okay, total 6 variables. Okay, g is the acceleration, that is also is taken as variable. So n is 6 and m is 3. So all these variables depends upon a mass L and T. So total independent dimension is 3. So there will be n minus m means 3 pi terms, 3 groups, 3 non-dimensional groups, pi 1, pi 2, pi 3. And in each group, so write the repeating variables and one of the non-repeating variables. So here we can write this repeating variables. You have to take geometric variable. It must have geometric variables like h. G is the acceleration, that is the kinematic variable, and rho is the mass variable or the dynamic variable. So h, g, rho is taken as repeating variables, and non-repeating variables in E1 is b out of the 6. Okay, g, h, and we have taken rho as repeating. So remaining b, d, and mu. We have to write in all the groups. Pi 1 in pi 1 b, pi 2 d, and pi 3 mu. Okay, so now we have to write the dimension of these variables m0, l0, t0. Okay, so we have to write the dimensions. After writing dimensions, we have to solve this a and b and c. So a1, b1, c1 will be minus half, 0. Similarly, here in the pi 2, it is h to the power a2, g to the power b2, rho to the power c2, d. So by writing the dimensions a2 or b2, c2, you can calculate. So pi 2 will be d by h. So here pi 3, okay, here mu is there. So I have to write all the dimensions. After writing the dimension, after solving the a, b, c, a3, b3, c3, you will get minus 3 by 2, minus half, minus 1. So here pi 3 will be mu by h rho b. It is a function, okay, it is into pi 1. Means this expression is also coming here. That's why it is written pi 1. So pi 1, function of pi 1, pi 2, pi 3 is 0. It is saying to means to find the expression for the velocity. So pi 1 is function of pi 2, pi 3, like this we have to write. So pi 1, write pi 1, this is the pi 2, this is the pi 3. So here it will be. Okay. So like this, Okay, using the dimensional analysis, the relationship can be developed. Okay, thank you so much.